As C# has matured, there have been a number of quality of life changes that can make your code simpler and easier to read. But often, these changes get lost in the noise of everything else. In this video, we're going to take a look at 14 ways you can simplify your C# code without turning it into an unreadable mess. Now, if you don't know me, my name is Tim Corey, and it's my goal to make learning software development easier. I have over 800 videos here on YouTube, including 7 full courses on the topic that will help you take your next step in your career. I also have paid courses on IamTimCorey.com. Those courses fund my free content so that everyone can have a great education in C#, not just those who can afford it. So let's jump right into Visual Studio, and we're going to just create a console app today. We're going to keep it simple, and this is going to be simplify C#. And we're going to say simplify C# app. And you can get this code down in the description below as a link to download the source code if you want a copy of this. So we're going to leave it at .NET 9. All the rest of the stuff we're going to leave as standard. And there's kind of a bonus one that I didn't decide we needed to talk about necessarily, but this is one of the code simplifications. That's program.cs doesn't need to have all of the ceremony around namespace and class name and method name and parameters and all the rest, when really the vast majority of that is special. It's not a normal method. It's not a normal class and so on. So this makes it a whole lot easier to start writing code. Okay, so that's kind of a bonus one. But let's dive right into the first way, and that is using static. So if I were to say console.writeLine and say, whoops, there we go, hello world. Okay, so you're all familiar with this console write-line. We use it a lot in console applications because we're writing out to the console, we're reading from the console, and so on. And really what this is system.console.writeLine. But this is part of the implicit using directives. So this system is part of the defaults for our using statements that are, again, another thing that simplifies our application. But that's not what we're talking about here. What I want to talk about is the idea of a static using. So using static console. Actually, let's go system.console. If I spell it right. So what this does is it allows us to put in here static classes, which means I can do this. So now if I'm doing a lot of write lines and read lines and writes and all the rest, I can just start typing write and say, my name is, etc., without having to say console first. Now, yes, just like with using directives, you need to think about stepping on the toes where maybe 2 different things have the same method name. So it's always something to think about, but with using static, it just makes things even simpler and our code even cleaner. And if you're familiar with console, well, then you know what writeLine and write and read, where they all come from. So it's not like it's hiding anything from you. It just makes your life easier. It makes sense to not write console dot all the time. So it's not just for console. It's for anything that's a static class. So you can do the math library and do if you're doing a lot of math in there, well then it's just absolute value and tangent and all the rest from the math library without having to say math dot. So this can be a real time saver. That's number 1. Now, number 2, and this is a more recent one, but let's say you have a list of string, and we'll call this names. You could say equals new list of string, and then you want to put something in there. So then you put the curly braces, and you're going to say Tim and Sue and Bilbo. Okay? That's how you can declare a list of strings. Well, but that's wordy. Right? So let's comment that out. And instead, we can say list of string, and we'll say names equals, and we're going to do the square brackets, say Tim, Sue, Bilbo. And this is exactly the same as all of this. And it's, again, when we talk about making things simplified, simplifying our C# code, I want to make sure we're clear on something. This is not about creating one-liners. One-liners is not the goal. The goal is more readable. And for example, on the write line thing, seeing console dot all over the place probably doesn't add anything to readability. Write line is pretty understandable what's happening. I'm writing a line. In here, this actually kind of detracts from readability because you have to start parsing it and say, okay, we're declaring a list of string and we're instantiating it, and then we're putting these values into that new instance. So now names has these three things, as opposed to saying, we've got a list of names and we're putting these three values into it. That is as readable, if not more readable, than what we're taking away. And yet we go 5 lines of code here versus 1 line. Again, it's not about one-liners, but it's about making things easy to read and easy to parse. Now, to be clear, if you had a string array called other names, you could do the exact same thing the exact same way. So let's just copy and paste this. Okay, so that would still work, even though a string array is different than a list of string. You might say, well, how is it doing that? Well, behind the scenes, the system knows how to instantiate these things the most efficient way and put this information in. This is still happening for the list of string, and it's happening a different way for string array potentially. But at the end of the day, it knows, okay, here's the best way to instantiate a string array with 3 values. Got it. As opposed to, this is the best way to instantiate a list of string with 3 values. So it knows how to do that. But for us, pretty much any array type, so list of string, even dictionary and other things, they can all be instantiated with just the square brackets. And that's going to instantiate it and put those values into that item. And you might say, well, how is it, skipping this whole process, the new list of string? Well, it knows what the type is. Okay, it knows right here. So it doesn't need to have that repeated again. So it knows what the difference is. And in fact, this is similar to another one of our time-saving things, and that is it's the target type instantiation. There we go. Got stuck in my brain for a minute. So let's just say we have a list of int called numbers. And I could say equals new list of int like so. But what I'm doing here is I'm repeating myself over and over. We don't need to have that repetition. We can just say equals new. Now, some people don't like this because they say, well, it's reducing things. I don't like but what's it reducing? It's reducing the text that isn't necessary. Do we need to know that this is a new list of int? We already know it's a list of int, and we're reading left to right. So if you read left to right, well, then the first thing you know is the type, then the name of it, and now you know it's been instantiated. So you don't need to know that we put that same type into this type because we already know what the type is. So this makes it easy to read, and it shrinks down the amount of code we have to write, and again, reduces the amount of text on the screen while increasing clarity. So that is target type instantiation. Now it's number, I think, 3. We got 1 here, we got 2 here, and we got 3 there. Okay, so the number 4. Let's talk about anonymous types. So this is one that's been around for a long time, but people misunderstand its real purpose. So often people will say, oh, I don't like var. Var numbers equals new list of int like so. I should say numbers 2. So this is functionally equivalent to this. And people say, well, I don't like that because I don't like people using var. I get that. I understand because, again, readability purposes, you're saying, okay, it's a type of some kind. There's the name of it. And now by instantiation, we know what the type is. I totally get that. And personally, a personal preference here is I like this previous one because it tells you the type up front, then the variable name, and then that's been instantiated. So yes, I don't love this idea, but there's a reason why var exists, and this isn't it. So let's just say this came up a lot when I was teaching the course on Dapper, when I work with Dapper for data access. Dapper allows me to very quickly get data from a SQL Server or to a SQL Server from my C# code into SQL and so on. So it's a very light micro ORM, and I got a whole course on that I was teaching. And one of the things that I want to do is pass in parameters. And so I want to create a class that has all my parameters. The problem is that I don't want to create a class for every single thing I'm setting parameters in for, because it's just one-time use. So what do? I say var parameters equals new, and then to start typing. So first name equals Tim, last name equals Corey. All right, and that is a new anonymous class. So A is a new string first name, string last name. So it's not actually a type where I create a class for it or even a record for it. It's just an anonymous type. Well, how do I declare that type for parameters? Well, it'd be very difficult. I'd have to say something object or dynamic. But this way, by saying var parameters, var allows me to then say parameters dot first name, and it acts like a fully functional class or record without actually declaring that record. And since I'm only using this one time to pass parameters into one particular SQL call, well, then I don't need to declare a bunch of junk classes I don't actually need. So var allows us to not have to declare things. We can just say, hey, it's an anonymous type. That's one of the reasons why var is so valuable, and one of the reasons why it was created. It allows us to create one-time use classes and other things that they don't have to be declared and create a whole bunch of junk in our projects. So number 4, var, especially for anonymous types. Okay, so let's create a new class. So Control-Shift-A, this is a shortcut too, but it's not really for a code, it's just for C#. Control-Shift-A, we're going to say, let's call this important logic. You may guess that there's no important logic going in here. It's just for demonstration purposes. Now, first of all, let's just remove and sort the usings. But here's another one that I've showed you before. I do it a lot because this is, in my mind, the way it should be done by default. So this namespace here, the theory behind this is, with these curly braces, is that you could do in one file, you could say namespace another item and have a different set of classes and other things in there in that separate namespace. But let me ask you, how many times have you put 2 namespaces in one file? And if you say more than a handful, then I would say to you, you're probably doing it wrong. Or, wrong is a harsh word, but is there really a reason why you're doing that as opposed to separating out files? Files are free. Create a new file. That way it's easier to identify your logic, easier to identify the things that are in your system. So multiple namespaces in one file is not a thing you should be doing every day. Therefore, if you're not doing it every day, then why is it we always have these curly braces and always indent, in this case, 4 spaces, but whatever it is, why we always have this indentation? We never use this space because it's only for one namespace. And that's where we get file scope namespaces, where we put a semicolon at the end of the namespace. It takes out the curly braces. That makes everything shift to the left all the way to the edge. Okay, so or at least one level in. So file scope namespaces make your code easier to read, and really they should be the default because you should be using those for about 98% of all of your namespaces. So that's number 5. Number 6, I'm actually going to create a new file for this, even though it could be in its own file if you want, or it's inside another file if you want. But we'll call this employee record. And this is records. Let's get rid of everything and say public record, employee record. int ID and string name. Okay. What has this done? Well, it has done the equivalent of this. Public, well, first of all, we should put a namespace here. Let's go ahead and do that. Which it should. Okay, it didn't put namespace there. I wiped it out initially. So namespace simplify C#. There we go. So this is the equivalent of saying public class employee model or whatever, like so. And then let's get the right brackets here. And then we'd say prop int ID and prop, if you spell it right, prop string name. Okay, that's roughly the equivalent of this is roughly equivalent of what we do here. Although there's actually some more stuff here, like it's saying required, and it's saying required, and it's saying init instead of set, which means that when you declare this record, you have to give it an ID and a name, and then those are read-only essentially from then on for that particular instance. And actually, there's also an override for toString in this that will return the employee record as a string that's not just going to say employee record, and so on. So there's a lot of stuff going into one line of code. Let's get rid of that using direct hook. So this or this. Now, I'm not saying these two are functionally equivalent. I'm saying if you were going to do all of this, including make it required and init and overriding the toString and so on, you could do all of that with a record. There's reasons to use classes instead of records. So please don't ever think that I'm saying you have to always do things a certain way. That's not what I'm saying. But this gives you an option to simplify when it makes sense. When it makes sense to have a read-only object, this is probably the way to go. So this is a really quick way to declare a record. I would love the same thing for a class, honestly. But this, at least, is a really quick way to declare a record that you can then use in the rest of your application. Okay, so records are number 6. Let's talk next about pattern matching. And to do that, let's go ahead and come down here. Pattern matching is number 7. So what we're going to do is we're going to say, let's go with object emp equals new employee, which I believe, employee record. Okay, and we're going to pass in this information, which it's not finding this. There we go. We have the using directive up top. Okay, so now we got a new employee record. We put it in the type object. So emp is an object. Okay, so we can do a bit of pattern matching here to say if emp is not null. Okay, what's going to do is check to see if this is null or not. And if it's not null, we could say, right line, it is not null. Cool. Okay, so pretty simple stuff. But what it's doing here is instead of saying, the not equal to, which works, but by saying is not, it reads like English. If employee is not null, then do this. Which, I don't know about your brain, but for my brain, it's much easier to parse is not null than the bang equals. Now, to be fair, I have been doing development for years and years, and bang equals just kind of rolls out of my brain as not equal at this point. But it took a long time to get there, and even still, sometimes I have to slow down a bit to make sure is it bang equals or equals, and so on. So with this, that's one type of pattern matching, but we can get better than that. So we can come down here. By the way, if I were to say emp dot, Notice the things that are not on this list. I don't have anything with the ID or the name. There's no ID or name available here. Why? Because it's an object. It's not an employee record. Now, it is an employee record, but it's in an object type, and the object type doesn't know about the employee record. So I can change that if I want. If EMP is employee record, I'm going to say E, and E.ID equals 1. Now, what did I just do? Well, first I checked to see if this object is of type employee record. I'm doing a type comparison. I'm saying, hey, is this type what object is? So is object an employee record? But if it is, and again, it reads like English. If EMP is an employee record, but then I say E at the end. What's E? It's a new variable. And if EMP is an employee record, we cast it and convert that to an employee record. So all it's doing is saying, hey, I know this is an employee record now, so I'm going to say this new variable is that employee record type, which means we can now access the properties of that employee record by referencing E. And that E only lives inside this if statement. So that is a way to pattern match a bit further and actually get information about that type and actually cast it into a new variable. So now we can say write line, and we can say, let's do one more, which is actually number 8 right here, and that's string interpolation, which is that $ first, which means we can put data right into the string. So we can say the employee with ID of 1 is E.name. Okay, which again makes our code easier to read because because the alternative here is something like we would put a variable here and then or a placeholder here, we pass that into a variable afterwards, and it makes it harder to read. Where with this, we just say, hey, there's the employee with ID number 1 is E.name. Here's a C# code for it, but this is readable enough to know, oh, I'm grabbing the name from that E object. So again, number 8, string interpolation, makes our code easier to read. Number 7, pattern matching, makes it easier to identify if something is one type or another. This is super helpful when you're working with multiple interfaces. Maybe you have a whole bunch of iDisposable objects. That's great, but what if some of them are employee records and some of them are employee models? Well, you could do a check here. If it's an employee record, then put it in this and do something with it. And if it's a employee model with another if statement, then put it into E2 and do something with E2. Okay? So that is 7, pattern matching, and 8, string interpolation. Both of them make our code easier to read. All right, number 9 is what if you had maybe an error or something else where you needed to identify what type it was. So we're going to say write line, and we're going to say string interpolation. There was an error with the, we're going to leave this blank for a minute, variable. Okay, so we want to grab the employee record, so the EMP variable, right? We could say just EMP variable, right? Well, here's the problem. What if I come up here and I'd say, EMP is not really descriptive enough. I do a control dot, and actually, nope, I'm going to right click on it and I'm going to say rename or control RR and say employee. Okay, so now it renames employee here and here and here, but it doesn't rename it here. So now I have the EMP variable. I come over my code and there's no EMP variable. What's that variable? Well, I hard coded it in a string. That's a problem. So let's undo this and let's change this. So instead of EMP, I'm going to say name of EMP. And all that's going to do, all this nameof does, this is number 9, nameof, all nameof does is grab the name of EMP, which is EMP. And you might say, well, why would we do that? Well, because again, if I come up here and I were to say employee and rename that everywhere, well, now it says name of employee, not name of EMP, because it renamed it, which means that my string is still correct even after the rename. So yes, nameof does add a bit more code to our error statement here, especially with the string interpolation, but what it also does is provide safety to us so that whenever we rename things or refactor things, we don't get into trouble where our strings break. So you can use nameof wherever, and it's a very fast process that just grabs the name of whatever thing you pass into it, whether it be employee record or the employee variable name and so on. It can understand how to get the name of that thing and put that string in place. And then if you ever refactor, it takes care of refactoring that too. Okay, so that is number 9. For number 10, we're going to go to our important logic. We're actually going to add some important logic here. And this is, let's just say public void for now. I'm going to say split name. Now, this is not terribly great code because if you have more than 2 names, it causes problems. Or if you have spaces in one of your names like St. John or something else, it causes problems. But this is just demo code. So string full name. And I want to say string array names equals full name dot split on a space. So if you pass in Tim space Corey, then you get the array is going to have Tim and Corey as 2 separate entries. I want to return both of those. How do we do that? Well, if you only have string to return, well, there's a problem. You say, which one do I return, first or last name? Or you put a space back in, all of a sudden I'm not really doing anything with this method. So instead, we can now use a new type, which instead of creating, and this is the other option you have, instead of creating a class or a record that is just for this one return type, I can use a tuple instead. What's a tuple? Put in parentheses like so, and I can say string to pass back 2 strings. And I can say then return names at position 0 and names at position 1. Like so. Now, again, please be aware, this is demo code because I'm not checking to make sure I have 2 of those. This could break with an exception if I have like there's no space, or there's 3 spaces, I only return 2. It just bear with me, it's a demo. So I can return 2 values using a tuple. This tuple isn't anything special. It doesn't last a very long time. It's just for one return type. But I can go a little bit further. I can give these names. So first name, and then over here I can say last name. Then I know what those 2 strings are, just like we name our parameters that are coming in. But I can return a tuple. So tuples number 10 makes it a whole lot easier for returning one time a set of data instead of trying to somehow, either create classes that are only ever used once for one return, or records do the same thing, or somehow returning like an array or something else, because that might not work if it's a string and an integer. It gets really messy unless you use tuples. And tuples, you don't have to have 2. Just so you know, it's Tuples, not Twoples. So you can have 3, you can have 4, you can have 5. So don't go crazy, but this allows you especially for return types, a really simple way to return more than one value, especially if you're only doing it once. Okay, let's call that method and just see how to actually see the results. So I could say, let's start with something simple. Var results, there's our var again, equals, well, I have to instantiate important logic, don't I? So important logic, logic equals new. And then say logic dot split name. It'll pass in Tim Corey, which we know is going to work. Okay, so if we hover over results now, we can see that it's a local variable that has two things in it. And in fact, if we were to say write line, we could say results dot first name and get just the first name. So that allows it to get both values back. Or instead of saying var, we could say is we want to say, oops, parentheses, string, comma, string results. And that would be the same thing. Only here what's happening is it's breaking it up a bit different. Notice it gets us right quickly on our first name. So what is it? Well, it's item 1, item 2, because I didn't give it a name. Now, if I undo this and put first name back, I could say first name, and now it knows about first name, and the second one is just item 2. If we do a dot here, it's item 2. Not ideal. We can also say last name, which that gives the full declaration. But again, that's a lot when we could get it from the declaring method by just saying var. So easier. We could also, though, this is what's called deconstruction. This is number 11. Let's say you're passing back two values. You don't want it into one object that has two parameters. We could say instead, we can say string first name, string last name, like so. And now it's just the first name variable. It created two variables for me for our return logic. We could even simplify this if you wanted to, get rid of the strings here, and we could say var, first name, last name. If you mouse over these, first name is a nullable string, last name is a nullable string. So that's another way we can deconstruct that tuple into two separate variables. So deconstruction number 11 is basically to split a tuple back into two different variables that are not related anymore. Now, what if you don't want both variables? In our case, we're only capturing first name. We're only using first name. So why are we creating a new variable that we really don't need? Well, let's just not do that. So we can say underscore. What's underscore? It's called the discard character. So what we're saying is, I don't want this. I don't need this. And I don't need to create a memory space to put this string when I'm going to just ignore it. Therefore, we can just use a discard character and say, yeah, I don't really need that. And now we're doing the same thing before. We're still using the first name, and we're not actually capturing a space for the last name. It's more clear that we're not using this second part of the return. Again, going back to clarity of our code. If you create a variable and never use it, you get people confused. Why do we have this variable? What's this? And it might also step on the toes of a variable down the line where you might have to overwrite it, or you forget that you already had a variable name, last name, and you try to create a new one. You're like, oh, I already have that. Why do all that if you're not using the variable? Therefore, you can use the discard character and just not store it. So that is number 12, the discard character for when you don't want something. Okay, so that's number 12. Number 13, for this, we're going to write a little bit of code. Again, this was code that I was writing quite a bit in my Dapper course. And that is sometimes you want to use a using statement. Now, yes, this is confusing. This is a using directive. There's a difference. So a using directive is just a shortcut. So it makes it so you don't have to type out simplify C# dot employee record, okay? Or important logic. We don't have to type that out. We can just type out important logic because it knows simplify C# is one of the using directives. And it's just a shortcut. It's not importing libraries or anything else. That's all it's doing is shortcutting for this particular file. That is different than a using statement. What does a using statement do? Well, it works with a interface called iDisposable. And what iDisposable is an interface that has one method on there. It's called dispose. And that method needs to be called at the end of the life of that particular instantiation of whatever class you're instantiating. So anything that implements iDisposable is going to have a dispose method on it that needs to be called at the end. Think of it for things like cleaning up memory allocations or cleaning up access to, in this case, a database, where you got a database connection open. You want to make sure that database connection gets closed no matter what. You always want it closed, even if there's an exception or something else that doesn't allow us to go through the happy path of our code. Well, with this, we can work with the using statement. A using statement, where we say using, allows us to write code, for example, var connection equals new SQL connection. And we'll just pass in test for a connection string, right? So SQL connection, let's do the, we need to install a package for this. Install package, it's Microsoft.data SQL client, not system. System's the old one. We covered this in the course, but now use Microsoft.data SQL client. It's the newer one with newer information. So in Phi install this package of that. Okay, so what this does is it instantiates a SQL connection to a database. In this case, that's an invalid connection string, but that's what it would connect to, is that database, right? So I want to make sure that connection gets closed no matter what, even if the application crashes. So I use a using statement. And a using statement only works on classes that implement iDisposable. So with this, we used to have to do this, where we'd say using, we'd wrap this in parentheses, like so, and then we'd say curly braces, and then put our code inside here. And this is still valid code. And whatever data access we do in here, at the end of it, at this curly brace right here, it will close out the SQL connection. Guaranteed. That's what it's going to do. Now, this is fine. This is great. And this works, and it allows us to scope how long our connection is open for. If we're only doing one line of code or 2 lines of code like I normally do in here for data access, well, then that's a very quick way of doing things. However, sometimes we don't really care about how long this connection is open for as much. So in this program.cs, if we close it at this curly brace, doesn't really matter because there's no more code after this. So in that case, what we can do is we can take the curly brace or the parentheses off and put a semicolon at the end. And now we can just do our data access. So when does this using statement close out our connection? At the end of the scope of whatever it's in, normally a method. In this case, it's inside of the program method. So it's going to end at line, 46, technically 43. It's going to end right here. But it's going to end when we're done this method, which is just fine. But why do we have 2 different options? Well, imagine you have a using statement for a SQL connection, and then inside of that, you have another using statement for something else, and another using statement for something else, which happens. All of a sudden, you have 3 nested statements that are pushing your code farther and farther to the right and making it less and less readable. Where with this, very easily readable, and since you see a using here, you go, oh, that's going to close this at the end of the scope, in this case, the end of our program method. So that makes life a bit easier to have that using statement without the curly braces. Okay, so that's number 13. Number 14, and this one is one that, again, people often have missed. Let's just say you have a string, we'll call it number text, and you're going to say 42, right? This is very common, especially if you're asking for, the read line from the console and saying, give me a number. They're going to give you a number that's actually a string. So you need to convert this over into a integer because you're expecting an integer. Well, the way we used to have to do it is say int number value, and we could initialize it at 0. Doesn't really matter. And then you'd say int.try parse, and we pass in the number text, and we'd say out number value, like so, and then we get our value back. And again, we have to make sure that try parse worked. But what this would do is send the number value out as an out parameter to this, this variable number value, which we've already declared. But why do I have to declare up here and then use it here? Let's simplify this. Let's get rid of that. It's going to give me an error. I can say out int number variable or number value. Now it's going to create this variable right here. If we're doing nothing but instantiating it in the previous line and then calling this, just do it all in one line. And again, it's not reducing readability. Out int number value, it's creating that number value. And now we can say right line, the number is number value. And as long as we pass it a valid number where it doesn't fail, then this number value will be 42 or whatever we pass in. Now, if it did fail, it would be 0. So that allows us to declare inline our new variable for our out parameter. So inline declaration makes things a bit easier and cleaner. We have to write less code while still being readable. And that is number 14. So there's a lot of stuff going on in C# that's made our lives easier. I love this one, by the way. This is probably my favorite change in recent memory. It's just super simplification because I always forgot the way to instantiate a string array or something else. But all of these things are meant to make our code more readable. It makes it much more easy to see, oh, if it's an employee record and the ID is 1, then do this. And you know, you're doing casting inline and you're saying, hey, I don't need that variable coming back, so therefore I'm not going to name it. And I've got a using statement, and I can just know that lasts until the end of the next curly brace, the end of the next scope. You know, the parse where we declare it inline, and so many of these other things are meant to make our code easier to read and simpler. Now, again, I want to reiterate, I am not in favor of one-liners for one-liners' sake. You can write a whole lot of code in one line and make it miserable. I recommend that you, every time you write a regular expression, that you clarify what that is with some good code comments and change those code comments every time you change the regular expression. But whenever possible, make your code easier to read because code is meant to be read by humans. And if you write your code in a way that is complex to read, it's going to be complex to debug. And yes, you're going to have bugs. So the more of these features we can have where it makes our code easier to read without increasing complexity, without causing other problems, the better. So I wanted to highlight these because I think these are all changes that in the right context can make your code better and easier to read. I'm not saying always do it this way. There are reasons, for example, to use var, as we've seen. And personally, I like to have the actual type up front because var doesn't tell you the type. Therefore, it's almost meaningless except to say we're instantiating something, we're creating something, but we don't know what yet. So I like this whenever possible, the actual type. But at the same time, I don't need to see the type repeated twice. So I prefer to use this shortened syntax. But there are times when var makes sense. So we're using an anonymous type, or we're passing back something like this. I don't need to declare first name and the discard character and all the rest. I don't need to declare all that if I can just say var in front of it and make it simpler. So use things that make sense in the context in which they make the most sense. All right. So that's the 14. There's lots more in C# that has made our lives easier. There's lots more that you can do to tweak your code to make it more readable, more understandable, and simpler. But these will get you started down that path. If you have others that you like, leave them down in the comments. Let me know. But anyways, thank you for watching. And as always, I am Tim Corey.